if you want to get a number that has that many factors, you can construct one using primes.
Okay. So yeah.
Just watch the imitation game, and it'll all be clear.
Yeah, but didn't win the Oscar, so it can't be.
Can't be that good. What should have won the Oscars?
I don't know.
Did you see Boyhood?
No.
That was really good. I think that should have won. That should have won, in my opinion.
I saw, or rather, I heard the actors on that on Wait, Don't Tell Me.
Yeah.
That's almost like seeing them.
Yeah. Okay. Let's see. Okay. Hello, everybody. So, how's everybody doing? Everybody had a good break? Put your hand up honestly if you're totally stumped by today's homework. Totally stuck in the dead in the water. 1, 2 people. Okay. Put your hand. Okay, down again. Put your hand. You found it challenging, but you did it. Okay, good. You had like a half a hand.
I know, I couldn't hear what you said actually.
Oh, sorry.
I heard the last part.
So you put your hand up just in case.
No,
Just
I
up and
just
down.
that you did it.
Yeah.
I said,
No, the reason I ask is because we were having a big discussion, me and Nick and Iyad just now, about the pace of the course. Is it going too fast? Is it going too slow? And our conclusion was it's probably going too fast for some people and too slow for others. What do you guys think? Just speak up. Just, What do you think? Just talk. Anybody? Yes.
I found this course to be, to have a lot of elements of independent study more than I thought.
Yeah.
Before.
Is that a good thing or a bad thing?
It's both. 'Cause
Okay.
It's frustrating, but then I learned much more than I thought I would.
Gotcha. I'm sitting down to make it less formal. So who else? Is it too fast or is it too slow? What comments do you have about the pace? Come on, you all have thoughts. It's very, very safe. Nothing's going to happen. Just tell me what you think. Pretend I'm your wife. Yes.
I'm not sure what you mean by too fast, but I know that I did the homework,
Yeah.
but I haven't finished reading.
Okay.
And every class it's like that, so it's as if I'm accumulating so much.
Every class of this
There's like,
course.
yeah.
You have a backlog.
Yeah,
Gotcha.
but I need to do the homework, so I kind of I feel constantly behind.
Gotcha.
Sort of.
So it's frustrating that way.
But it's not too fast because it's like, okay.
Yeah.
You know?
Gotcha. So it sounds like you're saying there may be a little bit too much homework, even though the pace of the lectures is okay.
Somewhat, yeah. For
Yeah.
reading,
Or,
maybe
yeah.
I'm slow.
Yeah, I agree.
You think that too? Yeah.
Yeah.
Anybody else? Any other thoughts about? Yes, please.
yeah, I agree with that. I think in class, like, I'm totally following what's going on.
Yeah.
I don't think you're like speaking too fast or going through the material too quickly.
Yeah.
But since we have so much work, and this could be because of the snow days or whatever, but
Yeah.
since we've had to do so much catching up on our own,
Yeah.
I feel like sometimes I'm sitting there, I'm like, I have no idea why this isn't working or whatever.
Yeah.
Obviously, you could go to TAs and stuff, but I feel like a lot of people are having similar problems
Yeah.
in terms of like installing the next step of Sinatra.
Right.
Not that I think most people got past the first part, but
Yeah.
that last part.
Mhm.
And I feel like I would guess that's too fast, but you
Yeah.
know.
Okay. Anybody feel like it's going too slow? Be honest. I mean, like everything so far I already knew. Yeah. Yeah. You guys. Okay. Pardon? You too?
It's not exactly that.
I mean, let me put it this way: it was a useful refresher, but it wasn't all new stuff for me. Yeah. Okay. But it sounds like it's only maybe 10-20% of the class. Let's talk about the homeworks where I have you guys do the example out of the book. I mentioned that in the email. What do you think about what I said there? What are your suggestions or observations?
I think you were right in saying like when you assign those, what we do is not read,
Yeah.
but we just like, go into the programming assignment.
Yeah.
So it might be good to have some of what's in the reading in the assignment, but also a little bit like extra,
Okay.
or something separate.
So
Like-
so another. I'm saying
So
again.
when we have like put or post methods, instead of just typing what's in the book,
Yeah.
have us make another web page or some other method
Got it.
that will do something similar.
But are you saying still have you get the stuff in the book to work, or leave that all together? Because somebody else said, well, make something like movies too, but make it with Sinatra. But give me something totally different from the book. Yes.
So personally,
I feel like I'm in a hurricane here. Yeah, go ahead. Yeah.
Personally, I would rather have something that's totally different from the book.
Yeah.
Because, so, you know, for instance, with this assignment, I felt like I was really frustrated with a lot of the things that weren't conceptual issues.
Right.
You know, where, well, actually, we got the same issues when I was following along with your YouTube video, where, you know, it would just be like, oh, spec is not found, this gem.
Yeah.
And that's fine. I mean, I know how to Google things.
Right.
And so, to me, it would have been more interesting if the assignment had been, you know, even if it was something very similar, but the assignment just said, okay, you need to make a Sinatra web server that implements get, put, post. Maybe you even say, you know, and it needs to have a user that has these attributes.
Mm-hmm.
And either you just tell us you should create the test for it, or if you want, you can give us some of the tests and say, oh, you know what? Here are things you should test. You should make sure that it doesn't return the password of the user.
Right.
You should make sure it, you know, does return their name correctly, their email correctly. Because that, I feel like I would actually have to think about it, and maybe I'd look in the book and say, oh, okay, let's see how they did it.
Mm-hmm.
But I know for this assignment, 100%, I just copied it from the book and pasted it in and got it, like.
Yeah.
100% agree with what you're saying, that something separate from the book would have made us all think more and we understand it on a deeper level. But because it is so much new information, I don't know, like maybe that's good as like a second assignment, I'm not sure. But I know that like if we do this from scratch without any templates or any code to look at, I mean, I guess you're right, there's a book anyway, so you could look in the book and then change it to fit the assignment. But for me, this is all new for me.
Sure.
So making something from scratch without any like base level would have taken me a ton of time.
Yeah. And you might also say you have the option of looking in the book and trying to do it, getting it to work, and using that as a basis for doing your homework. Yeah.
I like your suggestion in your email about giving us the source code for the solution that we can tweak it, like do something else as improvement, because I feel like they'll give you like the code that you need to, because this is all new to me too, so but I need to learn it, and then it would actually test what I learned to see if I could tweak it to do something else.
Yeah.
Yeah, I was gonna say something like what Eric was saying, but also agree with Luca. There's basically, I think for me the big theme is just like needing to understand this entire structure without really knowing what it is or having seen it before. Yeah. So being given some existing source code or some tests to be able to have a foothold for the structure would be helpful, as opposed to just entirely starting from scratch and deviating from the exercise completely.
Yeah, I mean you could, go ahead.
You want to say more?
No. I think maybe did I jump the gun?
No.
Sorry. Yeah.
I confused a lot about this assignment, but in retrospect, like some of the subtle differences between testing the service and testing the client library is not something that I would have done had you given me an assignment and said write a service with some tests.
Right.
And the fact that the code in the book was broken, for lack of a better word, was also great, because it went through and now I understand all of it. Because I had to understand all of it because it was broken.
Yeah. That was my plan all along. Yeah. Exactly.
So I appreciate it.
Yeah. I saw some more hands. Are all the points basically covered? So I mean, I think that I kind of like the Luca version a little bit, which is not to say here. I mean, I don't mind giving you the source code from the book because you can find it with a little bit of creative googling. It's on his GitHub website. But I'm not crazy about assignments that say here's the code, add a method, or here's a method, fill it out. Because to me that like takes away the hard part. You know, it's like, oh, here's a get, do me another get. Well, you just do pattern matching and you do it. So I prefer blank piece of paper, but I don't mind pointing you to the source code. And you can find it. Look by his name in GitHub. I'm pretty sure it's all there. So, yeah.
How about giving us unit tests that we need to code for?
Possibly, possibly. So what I'm going to change the next, when the next chapter comes along. Hello? No, I don't want that. I'm going to modify this. So let's see, next week, rather Wednesday, There's a lot of videoing and difficult stuff, but no coding. I say videoing, watching videos. And then here, the next one after that, we're going to have a Twitter API exercise that's not from the book, so that's safe. And here we have, so it's that a week from Wednesday, we're going to have chapter 3. I'm going to recast this one to be a new program that you write with my specs that uses the same techniques that this chapter illustrates, but without, and maybe even it'll turn out to be a project. I'm going to try that next time. We'll see how it goes. Okay? All right. Go back to my. Okay, so let's talk about building teams for the project. So we're going to be starting around now. We're embarking on a new little voyage, which is to build Nano Twitter, and you'll hear all about it in the next week or next day or two. Nano Twitter is your personal junior version of Twitter that's going to do a subset of what Twitter does. And the basic app should be fairly straightforward to write with Sinatra, but it gets interesting when we try to put a load on it to see that it doesn't scale, and then we're going to see how to make it scale. And I don't think it's, when it's all said and done, it's going to be a huge amount of code, but there's going to be a huge amount of learning. And so I've thought of this as a team project, and the question was how to put together teams. And after consultation with my brain trust, the current idea is that we say teams of 3 or 4 students, and you guys can put together your own team. Now, the reason I always am a little nervous about the second part is that what happens is, it's like me, I never got picked. I was very, very fat when I was younger. In fact, when I was at Brandeis, I was very fat. And I was always the last one to be picked on any sports team when they pick teams. So my concern a little bit of this is that I'm going to have the superstars in the class all be together in teams, and all the people that for this is all brand new are going to be in teams, and they're going to be really frustrated. So I'm just going to throw out that concern into ether and let it hopefully land in some fertile ground and tell you, please go ahead and form teams of 3 or 4 students and negotiate amongst yourself whatever way you want, and let us know in the next, I already see people making eyes at each other. Let us know in the next day or two who you're going to be with, and send emails to the TAs, let them know what your teams look like. And get it done quickly because we want to start assigning projects to teams. Questions? Everybody okay with the process? Everybody not okay with the process? Okay, good. All right. How about having a workshop again this week? We had a workshop before the break. Nick had a workshop. I think there were like maybe 6 or 8 students there. And the way it worked was it's like a super office hours. Nick and I both play. It's like multiple chess. We would run around to another board, help to solve a problem, run to another board, help to solve a problem. And the idea is you're together all working on it. You can overhear the discussions and get stuff done. So that's kind of the format, 2 hours. I hope if anybody's short, a few steps short of getting things to work or feeling like he doesn't really know or she doesn't really know why it worked, that you take advantage of this opportunity. And the time, the slots that we have available, and let's do a quick vote, are going to be Tuesday, Thursday, or Wednesday. So Tuesday with Iyad, Wednesday with Nick, Thursday with Iyad. And obviously we're only going to do 2 of these. We're not going to do 3. But what I want to do is quickly have people look at your schedules. We'll talk. I mean, the time probably in the afternoon, but that's flexible as well, depending on everybody's availability. So let's do a quick show of hands. For who would Tuesday be good? 1, 2, 3. Oh, a lot of people. 1, 2, 3, 4, 5. Okay, 5 people more. This is just a random sort of estimate. For who would Wednesday before class be good? 1, 2, 3. Okay, pretty good too. 5. Okay. And for who would Thursday be good? Okay, looks like we have more or less equal time. So what I suggest, no, it's okay. I want to see if any day was specifically, okay, now let's try times. For who would 3 to 5 o'clock on Wednesday be good for the Wednesday people? Okay, Okay, and for who with 3 to 5 on
Do you
Tuesday?
mean this Wednesday or just
This Wednesday. This Wednesday. Just once. If it's good, we'll do it again. We're just scheduling one for now. For who would Tuesday 3 to 5 be? Good. The Tuesday people, what time would be better?
3:30.
Pardon?
3:30.
3:30 to 5:30?
That's during statistical machine learning.
Okay, so that conflicts with people that are taking this class? So is 3:30 to 5:30 bad for the people who want it Tuesday? No, it's good. Okay. So I'm going to put 3:30 to 5:30. This is 3 to 5. If we do these two, does anybody who wants to come not be able to come?
Wait, what was the Tuesday?
If we do Tuesday 3:30 to 5:30 and Wednesday 3 to 5, does that cover everybody who wants to come? Good. I think we're good. So can you guys just send emails out and get people to know that it's happening? Maybe I'll do it myself. So this Tuesday, that's tomorrow, 3:30 to 5:30, and then Wednesday, day after tomorrow, 3 to 5. Good. Excellent. Fantastic.
What room?
Let's say Vol 101, but I don't know if it's available, so I'm just saying that.
Yeah.
It'll be a room that will be announced soon. Let me send myself an email. Well, does this actually work? Can I send myself a... I've never done that. I know. I'll take a picture of it. All right. Good. Excellent. All right. Moving on. Moving along. Yeah, so we're starting into this whole topic of service-oriented architectures, web services, scaling by breaking a big system down into services. So, and today's reading was kind of about that. So, for me, the key point, and I actually had it here as a thing to review again, and I'll review it again. It's very obvious, perhaps, but it's just important to just drive it home, drive a nail to the coffin, which is this idea. A web server that we all know is something I type a URL into my browser and I see a web page. Boom. Send a URL in, URL gets parsed, HTML gets returned. But in a world where a lot of interesting websites have a lot of data that maybe another website may want to use, like I have a lot of weather data, or I have a server that's good at giving astronomical observations or scientific measurements of DNA or whatever, there may be a lot of data there that some other product, some other system, some other website wants to use as data. So what are the choices? The choices are, I could type the URL in that would show the page of all of, let's call them baseball statistics just to keep it simple. Type the page that says, National League, blah, 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 and it would show me all the batting averages for all the players in a nice display, and I would get that HTML, and I could parse it, which they call web scraping, find the numbers in it, and thereby find the data I wanted to use it in my other product. That's what people used to do. They would take the HTML page that was meant for human reading, and they would parse it, web scraping, they still do it, and they would get the data from that. They could do further computation on the data. So, but that was a narrow conception of what a website or a web server could do. That was the original conception. But the broader conception that people realized years into it was, why does a web server have to just return HTML? Why can't it return data in a format that another computer could use? And so the second category of web server was invented, or was really a conceptual leap, which is a web server that instead of returning HTML, returned data in another form. Now, if you recall from what we looked at with HTTP, there's an HTTP request. It has a verb, get, put, post, whatever, and it has a response data type, a response format, text slash this, text slash that. But it's got to return data in some known format. So the question would be, if my web server was designed to be a service, that is to say, not to return HTML, but to return data, and I sent it a request asking for the winners, the batting averages of 10 players in in the National Baseball League, Major League Baseball, how would it return it? What format would it return to me if it was meant to be consumed by another program? Okay, so I'm sending a network request to your server. Your server contains the data with all the stats about all the players, and I'm asking for the batting averages for all the pitchers in the Major League Baseball. And it wants to return back to me their names and their batting average. How would it return it to me? What are some of the choices of what format it would return it to me? Take a guess. I'm going to avoid people that I know for sure know the answer. I try to get people to actually guess. Think. Would it return it to me as a picture? As an image? Would it return to me as an image? Come on. Why not?
You can parse.
Who?
You can parse.
Who's you?
Well, you want to use it.
Yeah.
You read it with pixels, so.
So sending a PNG file would not be a good idea. Okay, good. How about sending back an audio file with somebody reciting the numbers? How would that be? Would that be a good idea?
Maybe in 100 years.
This is geek humor. I'm telling you who the geeks are. Okay, so sending an audio file would not be a good idea. So what would be a good idea? I ask for the stats. I'm a server. I'm trying to write a nice report. I happen to know that the Major League Baseball server out in the cloud has this data in it. I want to ask for the batting averages of the pitchers of the Major League Baseball. I ask for it. I send it the URL. It sends me back the data. What format is the data in? Yes?
Can't the JSON?
What's JSON? Yes, the answer is yes, but say what it is.
I'm not sure exactly what it is, but it's an object that basically every value's in like a symbol, and then it's like keyed to a value.
Yeah, exactly. Anybody have any want to add to that? Let me explain. So what he says basically is, why not send back text, human readable text? Like I could send back CSV, pitcher name in quotes, comma, number, pitcher name in quotes, comma, number. That would work, but it's got some problems. The problem with that, sending pitcher name, comma, number, is what? It's perfectly acceptable, but it's got a weakness. The weakness is that the recipient has to know that it's CSV, okay, that's one, and that the first column is the pitcher name and the second column is the batting average. But it's not a bad solution, it's just not what people typically do. But it could send that text. So if I did a get, if I went to that little app that I showed you guys, I don't know if I've showed it to you yet, but if I could just do a get request to this mythical server, it could send me back a CSV, comma delimited file, and I could then easily parse that and find out what it was. Okay? But instead, what we're going to do is we're going to have our server send back JSON. Now, JSON is just another format or protocol or standard, whatever you want to call it. It's an agreed upon way to interpret data. Okay? And a JSON file in this case, I think, anyway, would look like this. Curly bracket, quote, pitcher, colon, Pedo, Salas, comma, ERA, whatever. I changed my 2.5, comma, done, comma, curly bracket, pitcher, colon, Nick Moran, curly bracket, no, wrong, comma, ERA, colon, 1.0. Curly bracket, close array. Can you see that? That's what it would send back. Okay? Now, the syntax is called JSON, which stands for JavaScript Object Notation. You will encounter in your Ruby readings another format called YAML, which stands for Yet Another Markup Language, which is 99% the same as JSON. And nobody outside of the Ruby world knows YAML. So by and large, we avoid it and use JSON. But if you ever see it, just know it's almost precisely the same as JSON. Okay? The characteristic about this that makes it a little bit more suitable than CSV, where the file would look like this: Peter Salas, comma 2.5, Nick Moran, comma 1.0. So this is CSV, and this is JSON. Okay, you can see they contain the same information. You can also see that the recipient of this data, that is the person or the application who did a get to this mythical server at the Major League Baseball to request this information, they said, when they told it what kind of response they wanted, they probably said text JSON or text CSV, if that even exists. But they told the server what format they wanted the data in, because why? Because the server has this information in a database. And all the silly Sinatra app is doing here is fetching the data out of the database and reformatting it into some textual format with an agreed upon syntax and sending it back. Everybody crystal clear on this? It's really important that you understand this. Should be review for 9 out of 10 of you in here. Anybody have a smidgen of doubt? Okay. So that's the crux of the matter. We're going to use this concept. This is like the foundation of the building. If this foundation is not solid, the rest of the building is going to collapse. So you'll probably find me repeating this many times. Who can speculate on why I said that CSV was a little bit less good than JSON in this case? Who can speculate on that? Yeah?
Doesn't contain schema data.
Okay, but why does that matter? Who cares?
So if you want your data to eventually conform to some sort of structure, you need to include the attributes for which these data values correspond to. So a JSON is a map that includes both the values and the keys and the values, whereas CSV only contains the values. And the column header for every CSV is the keys. So it's more compact, but but on its own is not able to tell the full story. You only get one side of the correspondence.
That's one reason, but that's a good reason. I mean, you can't put schemas in because conventionally, often the first row is the table names. So that is one reason. But yeah, did you have your hand on? No. I'm blinded by this thing, so I'm sorry if I.
Can't you have like arbitrary depth?
Yeah, that's the thing. So if you're going to pick one format, then this format goes a lot further. You know, I can have nested structures, I can have arrays, I can have hashes, I can have a lot more. So if you're going to pick one format and want everybody to learn one format, JSON is a little bit more flexible. Now you may have heard of another format called XML, which exists for a very similar purpose. XML actually is the underlying language to HTML. So this thing in XML, I will not write the whole thing, would look something like stats, result or picture, name, slash name, ERA, slash ERA, slash picture, and so on. Okay, so this is XML. It's even more wordy. It again would contain the same information. It's even richer. And the thing about XML that makes it special is that it's much more robust in dealing with non-Latin character sets. Okay, so XML is a more powerful language, but it's much more clumsy and much more cumbersome to write by hand. This is pretty quick to write by hand. So there are times when you'll say, no, JSON is not the right thing, I want to use XML. But for our purposes, JSON is fine.
So if there are a lot of like Russian pictures, maybe.
Yeah, exactly, yeah. I mean, and there's also, because there's more like at the global level and between countries and so on, not only character sets, but just interoperability. I mean, any computer from an IBM mainframe to something that goes to the moon, they all talk XML. So it's really the ultimate interoperability standard. But when you're talking about a known set of computers talking to each other, JSON is almost always used nowadays. And by the way, nobody mentioned the possibility of a compact binary format. I mean, why the hell don't I do, change this into bits? Forget all the quotes and stuff and just put blah, 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 turn this into binary, put 2.5 as a number, binary 2.5 as a number. That's another possibility. It's not the ultimate, it's almost the ultimate compressed format, but that's even less robust because there's no redundant information, so you can easily come to error cases that are problematic. The other thing that we'll see as we work through this course is that there's a real advantage to be able to human read the data that goes between two computers, because when things inevitably don't work and you're trying to debug it, you'd like to be able to look at the stream coming out of the mythical Major League Baseball stats server and look at it and see that it's correct and that the problem is on your side, not on their side. So human readable forms are useful as well. Okay. So this is if hopefully you did get to reading chapter 2, this is a little bit of what chapter 2 was about. It was building on these concepts, on what the deal is with service-oriented. Now, when service-oriented architecture as a term it's kind of a special nuance to simply saying web services. Web services as a term refers to the scenario I was just drawing for you, where the service is being provided by one entity like the MLB and another entity like Peto's baseball gambling site uses that service to get the data. That's a classic web services scenario. Service-oriented architecture uses that same technology or that same architecture, but as a way to break down one product, like Twitter, into a bunch of independent services. The plumbing, the underlying technology, the underlying ideas are the same, but it refers to taking one big problem, one big system, and breaking it down into individual components called services. And if you take Twitter, Facebook, LinkedIn, just about any non-trivial web application that you know of on today, or even mobile app, it's almost guaranteed that it's a service-oriented architecture, because that's the best way that we know of to make a system scale in a very large way. Okay? And one of the big learnings in this class will be understanding this concept and getting a handle on how you decide how you take your big monolithic program out of one big hello world into a bunch of services. Where do you draw the lines? It's very related, and that's why it's bundled together with the idea of object-oriented design. Object-oriented design talks about single responsibility principle. It talks about how to figure out where you draw the line, where should the method live? Should it live on one side of the divide or the other side of the divide? All those questions are the same questions that are applied when you design a service-oriented architecture, except the big difference is that object or class A lives on one computer that's in Boston, and object or class B lives on another computer that's in Tokyo. And so there's no shared information whatsoever between them. There's no data, there's no disk, there's nothing that's shared between them except for the connection. But it's still one system. And you can be sure, as I'm sure you realize, that when you go onto Facebook or Google, who the hell knows where that server is? And every time you type, it's a different server in a different country, a different part of the world that may be getting involved. And it's all invisible to you, and you perceive it as one application, Google. And so that is a classic, canonical, and probably the world's most complicated service-oriented system. Okay? So in this chapter, you saw mention of a lot of the terms we talked about in object-oriented design. Independently, the ability to test something independently. The ability to scale by creating more copies of the same service. If I have a service whose job it is to, and I think of Reddit in this context, or Imager, whose job it is to serve pictures, you can be sure that, and I think I heard an interview once, that around some big event in the public, whatever it is, that's going to generate a lot of pictures on Reddit or on Twitter, that they turn on a whole bunch of additional internal picture services. Their service-oriented architecture allows them to roll in virtually another server and another server and another server to handle all that load. The ability to do that kind of scaling, where you add additional servers to handle additional load and plug them into this big honking machine called Reddit or Twitter, that all comes from the service-oriented architecture as well.
Why not keep them running constantly?
Money. And it's big bucks that we're talking about. Big bucks. That's one of the breakthroughs. One of the reasons, by the way, I thought you should mention it, why the cost of doing a startup nowadays, one of many reasons why the cost of doing a startup, particularly a web-based startup, has gone down so much. Because just a few years ago, you had to try to figure out, let's say you're coming up with the next great thing. Let's say it's Uber. Even Uber, but Uber, yeah, maybe Uber is like that. Uber is not, but let's say Uber. And you got to figure out, well, let's see, we're going to deploy first in San Francisco, then we're going to New York. Okay, so we have to buy servers. Let's buy N servers because we'll need that. And then, suddenly the business is growing faster than you expected, or slower than you expected. If it's growing faster than you expected, you have to order more servers. Getting the server takes 3 or 4 days. You have 3 or 4 days of bad service. Or now suddenly it's New Year's Eve and everybody needs an Uber. Suddenly you need 10 times as much load. What do? Either you were smart enough and you bought them ahead of time, and you had them installed and set up and tested and configured ahead of time, or, and the rest of the year they're sitting idle, or you are able to just crank them up dynamically and literally turn a knob and more servers come online. So it's a huge money issue. But the interesting thing is that it's the architecture of your product, and we're talking high-level architecture here, has to be designed in such a way as to allow that. I mean, you can't. It's like saying my car is not going fast enough. I'd like to put another engine in, but if the car wasn't designed to take another engine, then you can want it all you want. I can't do it. And that's a lot of what people have been learning to do. A lot of the stuff is sort of like invented on the fly through necessity. And basically you have to design your architecture in such a way that it's possible to literally turn a knob and put a few more image servers in. And the big successful ones like Google and Amazon, that's what they've done. I mean, I don't know this, but I know this, because that's the only way.
Do they automatically get turned on, or does somebody have to flip the switch? Or do they?
No, generally I think it's because I don't know for sure, but generally I would say somebody has to flip the switch just to allow for anticipation, or I know it's going to be. I don't want to wait until people start complaining about bad response time to know that there's a problem.
It's not like the server starts noticing that it's meeting the load and it just flips on the switch.
I don't know. I think it depends a lot. I think that could be possible, but the problem is I think that by the time the server notices, then it may be already you're giving bad service. I'm losing money. How do you know whether people are buying less stuff on Amazon? Because look at Netflix is a great example. I mean, it blows your mind. But Netflix. When it used to be, we'd try to watch a movie on Saturday night, and it would be really slow, it would be freezing, and my wife would say, well, everybody's watching that movie. And I said, I don't think that's really how it works. I mean, it's not per movie, but it is probably per location and geography, that if enough people are watching a Netflix movie, that's going to start consuming bandwidth, and the scaling problem, well, we don't know what the scaling problem is. If I say, why is Netflix not showing, maybe the thing is freezing or it's breaking the connection, what is the problem? You don't have enough evidence there. It could be the server that's sending the video out into the ether. It could be the connection, the bandwidth connection through the ether, through the internet. It could be something about the way the client's written. There's many, many reasons. But point is that this whole question of how do you increase load and where do you increase load is very, very complicated. And that's why I'm not so sure that would be automatic. I think it would be more people are sitting in an operations center like NASA with big monitors and things flying. They go like, okay, it looks like everybody's immediately going to watch all the Academy Awards movies, so let's dial up the power of those servers, something like that. I don't know how it works. I just know it's amazingly complicated and very interesting because of that. Okay. Okay, now we're going to drop back into the mundane. So what is Sinatra? What is Sinatra? Sinatra is nothing more than a bunch of Ruby code. Ruby, okay? Sinatra is nothing more than a library to make it easier to do a lot of the canned stuff that everybody has to do when they're building a web server. That's really all it is. So there's no magic there. And the problems everybody or some people had with getting the example to work is not because it's Sinatra per se. It could happen with anything. When you're installing a new library, there's version skews, there's small typos, and who knows why exactly missing that slash was the key to the problem. I'd have to go look at the code to understand why that slash missing. One of the paths in Sinatra was, who had that problem again with the slash? Yeah. So which one was it again?
Is the GET request thing?
Yeah, the GET request. So it was GET, And you had?
I think it was like API slash.
API slash v1 slash
the name.
scroll user. Let's just leave it at that. And when you typed in that API, that into your browser, what would happen?
Nothing.
What would it say? It doesn't know that ditty?
Oh yeah.
Yeah, it would say I don't know that ditty, right? And that's the general error message Sinatra gives when it looks at the URL it sees, and it looks through all your paths and doesn't find anything that matches. So query, why wasn't this matching? Because there wasn't a slash there. Why did the slash have to be there? Anybody figure that out? Other than that's the way it is? Yeah. Yeah.
A slash is the root domain, so that's.
But what was this looking for then?
What
would this have matched without the slash?
Which slash? Sorry, which slash was missing?
Yeah.
It would have just matched HTTP. Like it would have matched not the subdomain of that. It would have like concatenated them, I think. So like localhost, like API, which is not an existing domain.
I wonder what the real answer, do you know? By the end of the class, Nick will have the answer. I'm just curious, because I went through all those different hypotheses and none of them made sense. And if none of them make sense, then I asked the Sinatra guys, why are you requiring a slash here? Why don't you assume it? But anyway, the point is that a slash was left off by a typo and the whole thing failed. So when you see Sinatra doesn't know that ditty, there's only one thing that it means. It means that the pattern that Sinatra knows how to handle, the patterns, none of them match your URL you typed in the browser. Now to realize that if this pattern said instead of get, it said put, it would not have matched, even with the slash. Why? Anybody? Yeah. Yeah.
So, because you were by typing into your browser, you're doing the get. You're trying to get something.
Yes.
And
Whenever
put
you
is kind of updating. I guess the user cannot do that like that.
Right. The browser doesn't do puts. The browser does posts, and the browser does gets. Posts are submits buttons in forms, and gets are type a URL in.
And puts.
Puts browsers don't do, right? I'm pretty sure browsers don't do puts. You have to do them through programs.
Put is update.
Put is update is specific. I mean,
you can't.
JavaScript can do a put, but the browser doesn't do a put, right? The browser, I don't think.
You can do it, but it's not like.
How do you do it?
I mean, you can send whatever request you want. You just change the headers.
No, I'm talking about a browser.
Oh, like a standard.
Like any browser, not just a standard one. Anyone. None of them can do it. Okay, but post is when you press the submit button, and get is when you type a URL in. And by the way, when I pick on somebody, I'm hoping that they will prove me wrong and call me on it. So I'm waiting for Ian to go. Okay, but the point is this: the browser, when you just type a URL in the box, is always doing a get. And so the Sinatra server will go through and say, I'm looking for a get /API, blah, blah, blah. I can't find it. I look through all of them. I can't find it. It says, I don't know that ditty. So when you see I don't know that ditty, there's only one thing it can mean. The URL you typed in does not match any of your get, puts, or posts in the Sinatra. Okay? Okay. So then if we, and by the way, this is all, I as you notice, when I try to explain this stuff, I go through it multi-level to try to peel away some mystery every time I go. So, so if we look at the structure of the Sinatra program, well, let's look at the one that we all struggle with. Yeah, okay. Here it is. This is all stuff you know. Basically, each of these sections is the key to the work. If the URL that the server has received matches this pattern, get blah 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 blah, it's going to execute this code and nothing else. If it matches this, it's going to execute this code and nothing else. So this thing is just sitting there waiting for requests. Yes?
Can I ask you slightly off?
You can ask me off and off and off and off.
Did you end up setting up your environment in the client.rb file then?
I didn't get to client.rb. I ran out of time.
Okay.
So I unwittingly left the hardest part off my video. It was not planned. But what was your question? I can answer it maybe from...
Well, the book has you set up the environment here, but Ryan's email was saying that it made more sense to set it up in the client.rb file.
He's washing his hands.
No, but I think the book. Sorry for calling you out directly. I mean.
No. He's he has a smile on his face.
Sense.
No problem.
He's a joker. I already know.
I was going to ask about that too.
So what environment are you talking about? When you set up the environment?
So like in the book,
Yeah.
the author suggested that when you have the test environment, that you initialize the test database values in the service file as opposed to in the client test file.
Initialize the test database values.
Right.
What do you mean by the test
When you
database?
set up the stage
If you
on
go to
the
service.rb.
test environment.
Like his service.rb has like put Paul and Paul at, the test data that he wants to test on.
Yeah.
He creates that test
In the client.
database.
Yeah.
No, he doesn't do it. He does it in the service.rb file.
Oh, okay, yeah. That's kind of bad design, I would say. I mean, it's not for his purposes. It's not unacceptable. But the reason it's bad design is now you're creating a dependency in your main program on what you happen to be testing, which is crazy. I think the right design is to have the client.rb, rather not even the client.rb, to have the RSpec that tests the client.rb generate the data. And in fact, the way you would do it, this is not in the I don't think it's in the work, but yeah, you could send it a series of posts. Send the server through the client library a series of posts to create the records, and then send it a series of gets to see that the records were actually created. That way, there's no dependency whatsoever, and you're testing two things at once, which is good too. Which brings up another point, which I'll get to later. So, and so the job of each of these suckers is to decide what to send back to the client. That's all it does, okay? And as we saw in this whole big diatribe here, it's not always HTML. It can be other things. HTML is the base case. HTML is where you sort of get your training wheels. HTML is what everybody needs to know. But if you're talking about a service-oriented architecture, then you're not sending back HTML because you're building the mythical MLB database server that has all the stats. Nobody's going to type in the URL to that server. In fact, nobody knows it exists. Because why? Because you have to pay money to access that server. And so nobody knows it exists, but you pay money. Now you have access to that server. You can write a program that grabs the stats out of that server. Okay? You're not sending it back as HTML. You're sending it back as JSON. The same bit of code can be written, and this will come up in the book. In fact, I take it back. This is the example we have here. It's not sending back HTML. It's sending JSON. So why is this say user to JSON here? Because it's saying taking the user record that it found in the database, convert it to JSON, which is that format over there, and then return it as the value, the return value of this call, which is what gets sent back to the server that made the request. If you're going to return HTML, which we'll get to soon, instead of this, you would have you bring into play view templates. And view templates are, have we talked about HTML and ERB yet in this class? I forget. ERB? No. Okay. So what's a view template? Well, let me just show you an example real quick. No, I've done a good one. Here's a good one. New tab, now I want to open it. Okay. This is a Rails program, so don't be disturbed by that. But if you look, that's not a good example. And maybe this program was not a good example to use. Hang on. I want to find one that drives home the point in a useful way. And that one does not. Let's try form demo. All right, here's a good one. Okay, this would be exactly the same if we were using Sinatra because it's using a component that exists in Ruby in general. So if you think about the fact that this Sinatra service would want to return a piece of HTML instead of JSON, that means that somewhere you have to have an HTML file. And HTML, as you probably know, looks kind of like this. You have things with angle brackets, open angle brackets, text, slash, and so on. So this would be a table, table header, title, table header, description, table header, owners, and so on. And then you'd have a body. And now you suddenly have some stuff here that looks nothing like HTML. This angle bracket star stuff. Okay? And this is what makes this thing an ERB file for embedded Ruby and not an HTML file. This file can be processed and turned into a pure HTML file. Okay? And that processing is a pre-process that happens within Sinatra. How? By executing essentially whatever code occurs between angle brackets as if it was Ruby. So basically, if you look at this, this is Ruby. Add items, each do item in vertical lines. It's an iterator, right? And now we have regular HTML, and down here we have end. So this is going to get executed once per item. And there's the word item, which is the local variable. And then for each one, we have, again, a little bit of Ruby. TD, that's HTML. Angle bracket equals item.title, pulls the title out of the current record. And so you can see here this whole thing generates a bit of HTML that reflects exactly the title of this item, the description, the owner, the category ID, and so on. So the ERB view or template is a way for you to speak to in a general way describe what a set of HTML pages will look like. Another diagram I think I've drawn, but it's useful to remember it, is that basically you can think of an HTML web server as combining data out of a database. Actually, usually it's data out of a database with, let's say these are all different names of people, different profiles, with a template. So this is the database of profiles. This is a template for how you want to describe a profile in HTML. I want the picture, I want the name, I want the last name, and given one person and a template, produce an HTML file, which can be sent off to the server. So really what a web server does when it's creating pages almost always is take data out of the database, take a standardized bit of HTML, combine them to produce a vanilla piece of HTML. Okay? So if we go back to the code we were looking at here, if this web service implemented in Sinatra would be generating HTML instead of generating JSON as its output, this code, instead of doing user to JSON, would be the moral equivalent of user to HTML. But it's a little more complicated than that. But in the end, still, this bit of code is what's playing. This is it. Okay? For this request. This is for this request. Okay? Okay. Good. Now, as you saw in doing the work, we were also, let me just separate this over here so we can have them both up at the same time because the screen is so huge. And I'm going to cover this in much more detail on Wednesday. This bit of code here is very important. Now, you guys all struggled with DB migrate and all this crazy stuff, even though I haven't really covered Active Record too well yet. I apologize for that. The sequencing is always tricky. But what is active record? Basically, active record is another library of code, which is the ORM, the object relational mapping layer, which lets me talk in object-oriented ways to a relational database. That's what it does. And as you saw, there's two steps. The one step is to actually create the database as part of the database itself. So it's a separate thing, in your case, SQLite. And the other part is how do you connect it to the Sinatra app. The effect of successful connection, which is what this code dealt with, which was tricky, I had a hard time getting it to work as well, is that I can do a bunch of operations on this Ruby class called user that correspond to database operation. So if I type user.find1 here instead of this, it's going to return to me the first user. So and I'll cover this more on Wednesday. But the only point I want to make here is that to achieve this, which is the job of this individual action in Sinatra, I have to do two things. I have to first find the record, and then I have to find the template, I have to combine it, right? So defining the record is using active record. And this code here basically is all about the complete collection of queries that you can do against the relational database, but written in Ruby. Okay? And this bit of code here, just in case it wasn't totally obvious, user in Ruby, false is false and nil is false. Everything else is true. Right? Get it right? Yes. False is false and nil is false. Everything else is true. So 1 is true, 10 is true, an array is true. So that's why I don't love this syntax myself because it's not clear. But I would have said user dot nil question mark, which to me is clearer. But basically this is saying if this find by name did not locate somebody with that name, user would be set to nil. This conditional would fall to here and it would return an error. So this is just simple error handling code. Okay? So, okay, I'm doing okay. Let's look at, actually, before I move away from routing, take a quick look at the Sinatra README.
Peter?
Yes, sir.
Can you clarify what the type user is?
Yes, this here?
Yeah. Oh no, the user equals user.findByName. So what does user.findByName return?
Okay. This is a call. User, if you put a breakpoint in here in pry, you do user.class, it would say active record something. So the class is an active record model class, and findByName is a method. It's a class method on that class, and basically there's a collection of methods, a large collection of methods. If you're interested in learning more about that, I will point to you at Rails Guides Active Record, which is a really good and really Rails independent description of the whole active. And I'll cover this on Wednesday. But check that out. It's very instructive. It builds up. But basically, to answer your question, there's a collection of methods that are automatically present because Active Record is clever. Active Record has examined the database on startup, actually at this moment, established connection. It examines the schema of the database and finds all the columns and creates through meta-programming a collection of methods that look like this. Okay, but there's things like user, I don't want to go through the whole thing, but user.where name : pedo, user.where, select. There's a whole variety of methods. All the result of all of them is an array of user objects. So user is a class. It's going to return an array of user objects that match this query. It's not really an array, but it acts like an array. Duck typing, so that you can iterate over it and you can, do all the counts and sort it and everything like that. So in this case, it's interesting that what would happen if there's two people with the same name? That may be a bug in this code. If you're looking for pedo and there's two pedos, this is going to return an array. And it may still work because user to JSON will work correctly.
I think there's a verification part in the model somewhere. So if you have the same name, I don't think.
Oh, it's not going to allow it? Okay. Yeah. Okay. But anyway, so that's what that basically is. So it's to reiterate upon this, which generally in this one line does a lot. It goes to locate the database, that it exists. It's a separate thing. It looks at the fact that it actually has a table called user. If it does, it looks at all the columns that user has, creates a lot of artificial or what do you call them, synthetic methods on it, and then allows you to operate totally on, applies validations, all this stuff, and then allows you to work totally within an object-oriented frame without any regard to relational databases, or whether it's MySQL or Postgres or whatever else. Okay. I wanted to show you this to remind you that these are very simple examples, but this is a very powerful and rich pattern matching language. So in a subsequent lecture, it's always like all these forward references. I'm going to talk about how to design a URL. I mean, to make processing convenient and elegant, you got to think about how your URL is put together, so that when you later on go parse them, they make sense, and also so they are sort of intuitive to a user. Because certainly when you're building a service-oriented architecture, people are going to be aware of the URLs. So you'll see here in this README a lot of examples. Okay, the very simple one is hello name, in which case Sinatra does the hard work for you. It parses, notices it matches, creates for you a params hash, which always is there, and at the key in that hash corresponding to this word, name, so the key is :name, the value at that key was placed there by Sinatra for you as a result of parsing the URL. Okay? Let's go a little bit further. You can also, they call this the splat. Where's the splat? I just saw it here. Here, splat, wildcard. So you could say blank to blank, and it'll give you a key in the params called splat, which returns an array of all the stars that occurred in the pattern. Not particularly useful, but you might have a use for it. Or it can do regular expressions. Now, not all of you know what regular expressions are, and I won't get into right now, but it's a mini language that's used in all kinds of programming languages to do pattern matching. And so you can write your pattern of your URL in some complicated way. Or you can have optional parameters. Post, where is it here? Dot, question mark, format, question mark, get, which matches get/posts, and any extension get/post.json, get.post.xml, and so on. And because it says :format here, the particular, so in here, in the body of this particular get, if I looked in params bracket format, I would see the words JSON or XML. If I typed posts by itself without a dot, that works because the question mark here says it's optional. Okay? And it goes on, and I won't go through it.
What if you type post with a dot but no format?
I saw that and I tried to ignore it. I think it would.
Never mind then.
Yeah, right. Thank you. My answer is they probably would allow it, but then give you a nil in the params for that's my guess. I won't go through this because you won't need most of it. I just want to point out that this is another case of keeping it dry. Do not repeat yourself. If you find yourself with multiple paragraphs in your Sinatra application that look very similar, you probably have an opportunity to use parameters more effectively, because it means you've repeated the same thing over and over again. Make the thing that's a little bit different a parameter, and build off of that. This README is full of good stuff, and I will not go through it. Okay. Talked about data. Okay. That's all we do right now for data. Let's see the time. We're going to 6:20, right? Yes. We're right on time. Let's go to ERB. I jumped out of order. Well, the only thing I want to show you about ERB actually is this. This is one of my many crypt sheets, and it's not a very good one. Take it back. I have to improve this. I have ERB demo. Let's see what this is. ERB demo. It's actually a good one. Very simple case. Forget about Sinatra, Rails, everything else. Here's a ERB file. ERB demo. We know our Ruby. Angle % means execute this as Ruby code. %W, you might remember, creates an array of strings. So I'm going to get an array of 3 strings. Jones, Hickey, and Salas, and Madeiras, 4 strings. Okay, so I'm going to array of 4 strings. I'm doing it each. I'm iterating over this array. And for each one, I'm outputting this bit of HTML. And it says, dear Mr. I'm using angle bracket % means this is a bit of Ruby. I'm going to interpret this bit of Ruby. And obviously that was matched with the first name. Dear Mr. Jones, I'm writing to let you know that I've moved. Sincerely, Tom, end. Okay, outputs that, does it again. So let's try this. This is a good one.
You should mention what the equal sign.
I should, absolutely. Thank you for telling me. Have you figured that thing out yet?
Yeah.
Okay, excellent. But not yet.
Unbelievable.
No, not unbelievable. Totally believable.
I had to read the HTTP protocol. It was terrible.
Oh, hardcore, baby. Okay.
First one.
Yes. Was that a question or was it a mumble? I guess it was a mumble.
You said I had to read the HTTP.
I would say the
HTTP. Finish your goddamn sentence.
Okay. So I just put this file in here.
Whatever the P stands for protocol.
I know, but it's the protocol called.
Okay, so there's this file, cat.test.rb that I just created, right?
Well, yeah, which protocol were you
Like the documentation of the document.
Okay, so now I do, hold on to your hats, ERB, which is a command line utility that I hope exists. It does, good. And I'm going to do ERB, and I'm going to do test.rb, and it's going to process this file. Who can predict what I'm going to see? Who can predict what I'm going to see? Come on. I know it's late, I know you're tired. Anybody can predict? Yes?
The text in between the angle %.
Yeah.
So it'll say dear Mr. and then the name 4 times. So it'll be dear Mr. Jones and then the paragraph, then dear Mr. Hickey.
Yeah, exactly. So let's see. There it is. Thank you. Excellent. Well done. So it's a form letter. That's what ERB is. ERB is a form letter generator. So let's go back and observe and look at this code again.
But it also took in the commas.
Say what?
You got one too many commas because it takes in the comma from the.
Oh, thank you. Excellent.
Yeah, but now the lab. Oh, okay.
Good job.
The professors wouldn't have liked that.
Okay. So, oh yeah, look at that. Yep, excellent. So, but now observe something interesting. Who can tell me what the difference is between angle % equals, over here, versus angle % without the equals? Who can tell me? And there's 5 of you who are not allowed to answer. You know who you are. Who can tell me the difference between those two? Why is there a difference, or is it just a typo? Doesn't do anything. That equal sign doesn't do anything. Come on. Okay, let me ask you another question. What happens if I remove that equal sign? Yes. Wait, I don't know if you may be on the list of 5 people not allowed to answer. Actually, the only people that are not allowed to answer are the people who try to answer. That's my system. No, it's very meta. No, go ahead. Sorry.
No, it doesn't. If you remove it, it doesn't print it out.
Okay, let's see what happens. Let's see if that's true. Okay, what happened? What went wrong here? What did I hear there? Why did it do this? Why is there no name? Yes?
It's not connecting. I mean, it's not reading from the array. It's just, it's doing it each time, but it's not printing out their name.
Because there's no equal sign. The equal sign says not only execute this code, but put the information in the result. Okay, you think you're so smart? Tell me this.
I don't.
What? Okay. What happens if I do this? And now anybody can answer. Anybody can answer this question. The list of 5 is not in play. Will it work? First question. Will it work? Say what? Mumble, mumble, mumble? I'm going to walk around. Will it work? That's not a representative. Will it work? 50-50. Come on, take a stand. Nothing. Will it work? Will it work? If I run it, will it crash my machine? Okay. It's a Mac. Okay. No, it won't crash the machine. It will work, but it will. Yes.
So the equal sign says basically this is a result of something that I calculated before.
Right.
If you have the equal sign.
Yeah.
It's like saying assign it to nothing, so it doesn't really know what to do.
Nope, that's not exactly right. But I'm glad that you answered. The equal sign says stick in the result text whatever the result is of this expression. That's why the equal sign with the name was important, because the result of the expression was the name. And it says stick. Let me do something else. Let me do something else. Let me make this change. I'm going to take this back and put it instead of this. I think that's the right syntax. No. What is it, guys? Is it random.rand?
Is
just rand by itself? Yeah, it is. Okay? Hickey 0, Sal 0, Madeire's 7. It's plunking in a random number, and every time it generates another letter, it's evaluating that same string and plugging in a random number. So if I took this equal sign away, well, it would still calculate that random number, but it wouldn't plug it in. Okay? So now, and it's doing this once per loop. Get rid of this.
What if you stored that random number in a variable?
Yeah.
With the equal sign, would it would still put it in because you?
Yeah, it would do both. It would store it in a variable and display the result of typing in a variable.
Okay.
So if you did, for example, % equals I equals rand 10, that's kind of what you meant, right?
Yeah.
Still works, but now over here I can put hi. Oops. So I typed the random number, assigned the variable I, pulled it back out here. It's the same context, it's a local variable. Okay, the punchline. I'm going to give you my guess because I'm not sure either, unless somebody wants to take a shot. My line of thinking is like this. What is the result of evaluating this particular expression? Yes?
I think it will be empty.
It'd be empty, like a nil?
Yeah, just nothing. Wait, work.
Yeah, I don't. Yeah, it's going to write something down. It could be a nil, or it could be that array, or it could be something else. I'll show you.
It's each element in it, or something crazy.
But there's one more problem with my hypothesis, which we'll see. I'll tell you what it is, no matter what happens. Wait a minute. Let me get rid of this stuff to make sure I didn't mess something up. Wait, I did mess something up. Hang on.
Yeah, the highlighting.
What did I mess up?
Well, highlighting's been off since you took out the commas.
No.
Something is off here. Hang on. Well, let's use the old undo. Right, that's more. No, it's really not reasonable.
Now there's no end.
Oh yeah. Still not reasonable, is it? If I do this,
No, I think this is right.
that works. Now I'm going to put the % equal in here. Whoever said it wouldn't work was right. Now, I have a theory. I have a theory. Somebody did say it wouldn't work. My theory that I realized as I was typing this was, that one unusual thing about line 1 is it's not a complete executable Ruby statement. It's a part of a block. So I thought to myself, ERB might have a problem doing this because there's no result to type yet. And that's why I think you get this crazy error message.
So what if you ended it in the same block?
Then your name would be out of the namespace.
What if I did?
So name's out of the namespace, but just out. So.
Say what you want me to type.
So all right. So what if you put end after the name in? So get rid of that end at the bottom. Yeah.
And put it up here.
And put it up there, and then you're also going to have to.
I don't think.
No, but not in the original block.
Oh. Well, I think then it should be okay.
And then you would just get rid of the name by Mr.
Yeah, that will just.
But not nested.
Anyway, this is not important.
That's what I'm saying.
It's fun, but it's not important. The important thing is to grasp, because I bet you $100 every one of you will sometime once have a bug that's because you put an equal sign in you weren't supposed to, or vice versa. Because everybody does that, so it's good to have this totally like nailed in your head so it doesn't waste a lot of time wondering about it. Okay, that's ERB, and that's exactly how you're going to accomplish this. Because instead of having a fixed array with names in it, you're going to have something like user.names, and that's going to be the thing you iterate over, and the body is going to be the display of the form. Okay? So, in conclusion, let me just get back to hide that, oh, too much. Hey, I lost it. No, next one.
That was the one before.
I know, thank you. Yep. Okay, I think we covered it. So the resources to look at, the Sinatra README is really good. The Active Record Guide is really good. On Wednesday, we are going to. There's some gems here that might help you if you're adventurous. You can take a look. They're not super important. The main thing I wanted to get out of today's briefing was the idea of a web service or a service-oriented architecture where a web server returns not HTML but data, typically in the form of JSON. The fact that Sinatra is nothing but a bunch of Ruby code, and the main program is divided up into these paragraphs which correspond to pattern-matched routes. The body of the paragraph is basically the thing that does the job of creating the output, whether it be JSON or HTML. If you're creating HTML, you're going to be using templates written with ERB, angle bracket percent versus angle bracket percent equals. And that's the game, okay? Next, on Wednesday, what do we do? On Wednesday, we're going to be doing, hopefully we'll have class, the way it's been going. There's going to be two things to do. One is easy, the other one is hard. Easy, assuming you use Twitter, which I bet 99.9% of you do, is to reinforce in your mind that you understand the functionality of Twitter. And just write a really quick bullet explaining what each of these things are. Okay, nothing complicated. I just want to make you go through and remember what they all do. Because your app, your nano Twitter is going to do all this. And the second thing, more difficult if you do it right. If you do it wrong, it's easy. There's two videos, both by this guy who, if you guys want, I can get to do a live telecast because he's a friend of mine. His name is Rafi Akarian or something like that. He used to be one of the chief architects of Twitter, and he describes, one of them is how they moved from Ruby and Rails to the JVM, which talks about their overall architecture. The other one is much more complicated. It talks about how they achieve the incredible scale they have. I found them fascinating. I hope you will too. And the way I'm going to ask you to watch these videos is by having a piece of paper next to you and try to draw out a block diagram of the architecture of Twitter and annotate it the way you want. So you can, okay, there's a server that does this, a server that does that. There's no right answer because, depending on the granularity you pick or the terminology you pick, it's going to be a little different. but it's going to force you to try to keep straight what he's talking about. Okay, and that's basically it. And then the punchline is that there's a really fundamental core difference in the way Twitter achieves scale. When I post a new tweet and 1,000 people see it, my followers, versus if you do a search for my hashtag, how do you end up seeing that? Those two things are totally different in the way they're implemented, oddly enough, and they're both about scale. So that's basically, it's reading and writing, there's no coding. And then that's it. So remember the 2 workshops, one tomorrow, one Wednesday. Remember, form your teams, and that's it. See you on Wednesday. Oh, why?
Why doesn't that thing work?
No, yeah, they without the flag. Well, what would it do? What is it matching for?
Okay, so when you get an HTTP request,
yeah,
it has to give